Hi there! More junk to play with and more printer. Well, it's only one printer, but it's a huge one. And it's still working, mostly. It has a couple of parts missing, but we have many of those standing around, and this particular one has to go now. So, before we take it apart, I will show you how it works. It's an IBM 6400 model 015, and that means it makes 1500 lines per minute, and that's pretty fast. So let's see what it can and how it works. So the print mechanism here is a Shuttle matrix printer. That means it is some sort of line printer, but it has needles like a matrix printer, but it has needles for the entire width of the paper, so it can print more or less one entire line at once. Advance the paper, prints the next line, and so on. By the way, this printer was manufactured in about 1998 until maybe 2005, 2006. This model here had its last firmware upgrade in 2002. We can see that when we print out the specifications. So the first thing we need is to install the printer ribbon with the ink on it, and it goes between two separators. One separates the ink ribbon from the paper, and the other one separates it from the printhead. I hope I can get it between somehow. Yeah. And it goes here and up to the motor here, to the hub. So, okay, now it fits. And it spools from one side to the other, and when the other side is empty, it reverses and spools back to that side. Okay, then we need to load some paper. On the front there is a compartment for fresh paper. We need endless paper like that one. And on the back side is another door where you can reach the used or the printed paper. So we have to feed it from down to the upper side here. And before we feed some paper, we have to open the platen, so the pressure bar that is behind the paper, where all the hammers or all the needles hammer against. So when that is open, we can move the paper through that slot here. Then we open the tractors. Yeah, they're already a bit worn here. You can see the fabric inside because the rubber has peeled off. Okay, let's check that. Yes, it works fine. Let's turn it on. Okay, seems to work. So we press stop. It says not ready. Well, because I put it offline. Then we can test line feed. Yes, paper is feeding up line by line. We have a form feed. Yes, it jumps one entire form forward, and we have a micro button here. We can do micro steps to fine adjust our position on the paper. And that's interesting, I haven't noticed that before. When I advance forward, the platen adjustment, the paper thickness adjustment stays closed. When I push the reverse button, it opens the platen, because the paper would probably jam between the platen and the ink ribbon. And when I go forward, it closes that again, so it does that automatically. You don't have to think of that. That's nice. Attention to detail. Okay, let's print something. So the easiest way to print something is to print the configuration sheet. One button and start. Well, of course, that sounds a little bit like a chainsaw, so you normally have your top cover closed, your door closed, and we try it again and listen to the difference. Is quite a bit more silent, isn't it? Well, the printer also has some built-in tests. We can select that from the menu, then jump up until we see something like operator print tests. Enter. Printer demonstration, that's nice. Enter, and it says locked. So to unlock, we have to push the up and the down button here simultaneously. Now it's unlocked, and we can do that. Well, that's the demo print, and as you can see, it is capable of printing graphics. Well, in this case it's only big letters, but you could also print any kind of graphics. The resolution is about 180 by 90 dots per inch. So 180 in this direction and 90 in that direction. It can also print different fonts. So because it's a graphical printer, you can print any font you want. Even OCR A or B, high-speed printing, that's a little bit less dots. Data processing, that's a better quality, and that's probably the best quality you can get. So that's what this printer does. So why it is called a shuttle printer? We will have a look at that right now. By the way, that printer is not manufactured by IBM. It only has an IBM front panel here. The original manufacturer is Printronix. you can buy this printer from them or from many other manufacturers who just relabel that. But Printronix is the inventor of that thing. So it has 2 screws here. Yep, that's already it. Cover comes off. And here we have access to the shuttle mechanic. So that's the motor with a large flywheel here. And as you can see, it has some sort of crankshaft with bearings. And well, it works like a piston engine more or less. So one is actually moving the head, that's the part here. And here we have a counterweight, because without that the whole printer would simply jump around in the office like crazy. So we have a head that has a certain mass, and the counterweight has certainly the same mass. And if we look at the wheel here, let me show you that a little bit closer. So you see it has teeth, but they are not for driving it. There is a sensor somewhere underneath that senses this teeth, so it's a magnetic sensor or a metal detecting sensor. And there is one teeth missing here. You see that? That's the signal for a complete revolution of that wheel, because it's only one teeth missing. Here is a hole, but that's only for a screw to secure the teeth on the wheel on the shaft. I don't know what kind of motor we have here. Is that true? Is that the motor inside, or is it just... Okay, we will see. So now how does it work? Well, here on this bar that slides left and right, we have a bunch of mechanical needles driven by electromagnets. And let's say that's the entire width of paper. You would need probably 1000 needles to cover the entire width here. So they do that trick. They take, I don't know, 20 or 30 needles and move it, shuttle them back and forth. So every needle gets to any position on the paper until the next needle gets that little part of the paper, and so on. And so they cover the entire width of paper with only 20, 30 needles. I don't know how many there are. Maybe we have to change the count then. And here you see an example when one of the needle is not working. You get a gap of about 1 centimeter. So that's about the movement of this bar here. So that's one needle not printing, and then the next needle is printing again. And you also see there are letters missing, there are characters missing. Yeah, maybe sometimes it works a little bit. So that certainly needs some adjustment, or maybe a couple of new needles, but we don't do that. And this is the back side, the back door. Here is the tray that catches the printed paper, and there are some chains here hanging around, and they simply guide the paper down and make that it folds correctly again. So you can see that here, paper comes down, folds itself to its original shape as it was in the box on the front side. And the chains here should prevent that, well, it does something nasty here. Okay, it should prevent curling, but yeah, that's the end of the paper. It's always a bit difficult, but under normal circumstances that works pretty well. Another interesting detail, we have a handwritten serial number here. Or probably that was from an update in 2001, package purchase date. So someone bought a package, a software package, or an additional piece of, I don't know, another interface, something. And by the way, there are the interfaces. I think that's a serial port. And here the parallel port connector is missing. Maybe someone has taken that for repairing another machine, whatever, another part missing. Okay. Well, let's see if we can take that Shuttle matrix printhead out. I think it could be quite easy. There is one screw holding it down. There is another one. There is a cable that has to go. And there is another one. And I think we have here a third cable. Yes. And a fourth. So everything is disconnected, but I see another screw here. I'm pretty sure that must go too. It's a captive screw. Doesn't come out, you cannot lose it. That's not bad. Okay. Yep. So I think we have to move the tractors out of the way, and then we can actually lift that out. That's pretty good for servicing. That's the Shuttle engine, the print engine, the Printhead. Yeah, we could call that the Printhead. And on this side we can see the holes in this separator sheet here, and for each hole, for each needle there is a hole. Let's count them. And we got 102 needles. This is now a Shuttle matrix line printer. The classical line printer doesn't have needles. It has a long band with all the characters on it. They are well engraved, stamped in it, and that continuously spins around in front of the paper. And when the right character is the whole alphabet and all the numbers are on that band, when the right character comes and is on the right position, a hammer from the backside pushes that character to the ink ribbon and to the paper. And of course you can only print the characters that are on this band. So if you want to change a font, you have to actually change that band to another one with another font. And of course it's not possible to print any graphical things like bigger letters or underline or bold or normal letters. And here with this Shuttle matrix printer you only have needles. They make individual dots, and with individual dots you can create whatever you want on the paper. So let's see how that works. So that's the separator. It's just a foil of stainless steel with a bunch of holes. And you also see there are quite some marks from the ink ribbon here. So the ink ribbon has finally ground stainless steel, and sometimes it grinds so deep that the steel here breaks. And you also see the ink ribbon goes diagonally across the holes, so that the entire ribbon will be used and not only one strip of it. That's a simple design. So there is another plate that looks a little bit more massive. Let's see what's behind that. All right, here we see the needles. They are not, well, I think I removed them. They are arranged in groups of how many? 10, 20, something like that. Okay, it doesn't stick, but well, it's quite a strong magnet here behind that. So it simply holds. Where is that magnet? Yeah, it's somewhere here. I think behind that strip must be the electromagnets, the coils, and there's also a permanent magnet. Maybe to pull the individual needles here. Where is my camera? Here. Back, so you see that. Come on. You can see the needles. They stick out on that side. Yeah, that's the needles of this Shuttle printhead. So, how far can we go further? You can also see that the whole shuttle mechanism doesn't have any bearings. Slide or ball bearings doesn't work. It just has this flexible spring here, and that allows enough travel, at least for that counterweight here that goes around the head, and the head does the opposite direction, but I think it's also mounted on springs. Can't see it. No, the head is actually on sliding bearings, some sort of. You can see them down here. That's one bearing here that slides on a shaft. Probably we can see that. Yeah, you can see the shaft here, and that I don't know why they do that. Probably, well, if you have it mounted on springs, it doesn't stay level. So if we move it to an extreme, it would move like that on a spring. So it goes up to a maximum and down. So because the spring is flexing and the position moves. So with this slider bearing, you always have a constant height of the needles, and that's important because we are talking here about fractions of millimeters that must be precise. Okay, so where are the coils? That's the question. So that's the Printhead bar. We have some really thick tracks here for power and some thinner tracks for data. Yes, also here, large connector for power, small connector for print data, and we have a large PCB here with all kinds of chips. What kind of chips do we have? I can't see that. Well, maybe if you want to search that, you can do this. Look a little bit like MOSFETs, certainly drivers for the coils, and that's some kind of decoder. And here we have the linear bearing, perfectly ground steel, smooth surface of course. And here is the other one, and all that dust here, that's just paper dust mixed with a little bit of oil. Let's see if we can dig deeper here. Well, I don't think I can do much with this, because it seems the entire magnet block here is just potted with some super hard two-component compound. So the entire magnet block here is literally one block. And you can see here there are the individual magnets here soldered to the board, and everything is glued into this frame, this aluminium frame here. Yeah, I think we can't go any deeper, but I think you understand how it works. So that needle is pulled back by the magnet, and I think when the electromagnet is energized, it acts against the permanent magnet, and this needle is released and flips forward and makes a dot on the paper. That's how it works. And here is a little detail on the flywheel assembly here. You can actually drive the wheel when I play the piston with my hand. So we have a boxer motor like the old Volkswagen Beetle. The only difference is Beetle has 4 cylinders and a little bit more stroke than only 10 millimeters. And if we look closely down here, let me turn that a little bit, you can see the sensor here. That's the sensor with a screw to adjust the distance to the wheel, and that picks up these gears here, these teeth. So every tooth makes an impulse here. I'm pretty sure there is a permanent magnet inside. No, can't feel that. Maybe it works with another principle. And the difference in height, so the tooth is higher, the valley is a little bit deeper, you get impulses here on this connector. And for every full revolution you have that missing tooth here that will also be sensed by the electronic controller, and so it knows exactly in what position the wheel is, and the bar with the dots with the needles and everything, and it can start printing. So did you ask where is the electronics of that beast? Well, I found no way to get to that from the bottom, so I think we probably have to move that. I already loosened the screws here. We can remove that cover. That looks pretty nice, like an old science fiction movie prop. And there we see a little bit more. And yes, I have already unplugged the mains connector. Important service information for proper cooling and blah 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 blah. Whenever AC power, yes, be careful. Fan must be running. There is the fan. And I also found the parallel connector. It was simply fallen out, so pretty lucky that it didn't short anything here with these wires and the metal case. So someone just stole the screws from that connector, so it fell back into the machine. Don't know why that happened. Okay, that's the processor board. You see a lot of yellow dust, so they must have printed on yellow paper or something like that. Power supply, relatively, simple. I wouldn't call it simple. I think that's the primary side. Mains input down here. Primary capacitor, switching, 2 transformers, 3 transformers, so they probably have a power supply for each voltage. Oh, there is a wiring diagram. So if you want to, it's also a little bit dusty. Yep. So I hope you can see that. The sun is blinding a little bit. And there are the output wires. It's not a huge current machine, so I saw on the type rating it's about 500 watts. So it has 2 red lines, maybe 5 volt, maybe 24 volts or more for the hammers. Do we have that on the schematic here? Well, I don't find it now, but yeah. No huge currents. We have some RAMs here, RAM modules. So for larger print jobs, you need to have a little bit of memory. What memory do we have here? Can't say that. Must be something special. Yeah. Or is it flash memory? Oh yes, it's 29F. So that's flash memory. That's where the firmware sits. So you can actually change this firmware memory module and replace it for a firmware update or something like that. Let's see if the other module is a RAM. Yep. That looks more like a RAM. Hyundai. Can you read it? I can't. I don't have my glasses with me, so I can't see on the camera screen what it is, but you on the big screen certainly can see it. I can only see if it's upside down or not. Yeah, that looks like a RAM module. Is there a size? No, just a part number. So that's not an IBM part number, that's a Printronix part number. What else do we have down here? Well, a bunch of driver transistors. That's probably for all the motors. We have motors, we have a plate motors that opens and closes the plate. I can show you that here. plate motor. Then we have a PPR motion detector. Paper motion detector, paper out detector. So it detects if there is paper or not. Left ribbon guide, left ribbon motor. Oh, the ribbon guide can also be adjusted. How is it doing that? Don't know. Seems they are pretty screwed on the frame. Hammerbank fan, I see. There is an extra fan only on the hammerbank to cool it and also to blow some dust away. Shuttle motor. Yeah, a lot of stuff going on the board here. And that's pretty everything. And the whole rest of the case is only paper storage, front and back. There is also a pedestal model of this printer that only has a stand, and the printer engine, only that part stands on top of that. But they are not so popular because they are much more noisier. Because here, if you close all the doors, it's pretty silent, relatively. But if all that stuff is open, all the paper feed holes are open, yeah, it's getting pretty loud. So, I think that's it. Thanks for watching.